Good afternoon, students. Today we will study about aging of bitumen. So the bitumen we know it's a volatile component, right? It has some components which is volatile. So volatile means it will evaporate upon application of hot air or wind. So due to this volatility, right, the bitumen will undergo aging. So aging means the whatever the components will evaporate, the volatile components when they evaporate, right, the bitumen will become slowly harder and harder, right? It will increase in the stiffness. So if the stiffness increases, the bitumen has more tendency to undergo cracking. Though it becomes more stiffer, but when it's a colder temperature, the bitumen can become more stiffer and can undergo cracking, right? So to see how the bitumen's tendency to age, right? So we will do something called as aging test. Before doing for aging test, we will see what types of aging will the bitumen encounter during different stages. So what happens when the bitumen is being mixed in the right in the mixed plant with the hot aggregates, the bitumen will form a thin coating around the aggregate, right? So during this process, what happens? The bitumen will undergo something called as short-term aging. From the process of bitumen heating in the mixed plant to the process of compaction, right? You will produce the mix, you will transport the mix, then you will lay and you compact. During these processes, the bitumen will be subjected to a temperature of, let's say, 135 to 170 degrees. So a thin bitumen film at this temperature, right, will start and losing its volatile components. So this is what we call as short-term aging. So why short-term? Because it is subjected to a very short duration. From the time it is being mixed with the or being heated in the mixed plant to the time it is being laid and compacted and until it cools. So that is called as short-term aging. So in short-term aging, the bitumen will be as a small coating around the aggregates, so which will undergo aging and we call it short-term. On the other hand, what happens? Now when the bitumen is subjected to service, now it is serving as a road in the form of, right, for longer time. So what happens? It will be subject to wind, air, water and other kind of climatic forces. So these will slowly oxidize the bitumen, right? Because the bitumen is exposed to the oxygen and the air. So it will oxidize the bitumen over the period of 20 to 15 years. So during this period, again the bitumen will slowly start losing its volatile components, right? And then becomes harder and harder. So that is called as long-term aging. Long-term aging. Now, long-term aging will happen when the bitumen is exposed to the environment or climatic forces. It is when you compact and allow it to serve as a pavement, then it will be subject to different forces and then slowly it becomes harder and harder. This way, there can be either short-term aging, one in the initial stages, then while serving it is long-term aging. Now we need to see that if bitumen has a tendency to undergo a lot of aging, then what happens? Whatever we design, right, in the during the design process, or whatever binder we selected, properties will change very drastically. That means, let's say you are designing for a VG30, depending on the climatic conditions what the pavement is serving. But if the bitumen, this particular bitumen, whatever you used, has more aging tendency, in a small duration it can become more harder. Let's say it turns out to be VG40. Now, since this was started based on a colder temperature, quite cold temperature, if you go for a VG40, it becomes VG40 because of aging. Then what happens? It have tendency to undergo cracking. So this way, the bitumen should be less age resistant. Right? If it is undergoing aging very faster, then we will encounter very harder binder in a short duration of time, which will develop more cracks, such as fatty cracks or low temperature. Those kind of cracks will occur in the pavement. So now, for any binder to be a good, it should be less aging or more age resistant. So now to simulate short-term and long-term things in the laboratory, we have two kind of equipment or two kind of tests. So one is this short-term we simulate through Rtfo test. So this Rtfo is called as rolling thin film oven test. So the bitumen we coat the aggregate as a thin film. Now that thin film has tendency to undergo more aging, right? So to simulate that, we will subject a thin film of bitumen for a short-term aging. Now, in this particular test, this Rtfo test. It has certain equipment to do. We will show you in the next set of videos. And then for long-term, aging, what we do now, when you long-term aging, the bitumen is subjected to oxidation, wind, and different forces. Now, the whole 15 years thing is difficult to simulate over long duration. So, what we do, we will try to accelerate in the laboratory by applying a high air pressure and high temperature using pressurized aging vessel. Pressurized aging vessel test. So what is called as PAV test. So we have one is Rtfo test and another we have PAV test. Now the Rtfo is used to simulate short-term aging and the PAV is used to simulate the long-term aging. So we will now start with the Rtfo test, right? And we will see how the apparatus looks and what is the different components of the apparatus, and we will see how to what this particular short-term aging will give you output. Now this is the rolling thin film oven apparatus. So now if you open this door, so we have certain components in it. So basically, since I told you it has to simulate the hot air conditions, so we use the oven. So this oven is a temperature controlled oven where we have components such as, one we have thermometer, right, to measure temperature. Then we have this particular heating arrangement which will supply hot air. Now, hot air is basically simulating the air which will be subject to the really mixing shell of construction. Now this has one particular carriage with some holes. Now this holes, inside these holes we will keep these particular Rtfo bottles, right? Now these bottles will be filled with the bitumen of approximately 35 grams. Whatever bitumen you want to study for the aging purposes, you will take a bitumen and you will fill it inside this bitumen. Now when you fill it, what you will do, you will just roll it. So when you roll it, what happens? It will form a thin film in the inner surface of the Rtfo bottles. Now this thin films you will place, once you get this thin film, right, and after allow it to cool for room temperature, you will place this particular oven, this glass bottles inside this carriage. Now this is the carriage. In this carriage, you will fill this particular Rtfo bottles. Now inside this Rtfo bottles, you will fill the bitumen whose aging properties should be determined. Now the aging properties can be, let's say, before and after aging, what properties may change. It can be penetration, softening point, or any other rheological parameters you can study before and after aging. And second thing, you can study the mass loss. Like before aging, let's say you put some mass in this particular Rtfo bottle, and after aging, what is the mass? So this will indicate what amount of loss of components are being happened when the bitumen is subjected to a high temperature. So now usually you will put 35 grams in this particular Rtfo bottles, and once you put, you will roll it so that it will form a uniform thin coating in the inner surface. So if I show this typical, let's say, here's how it will look. Now this is an Rtfo bottle filled with bitumen and rolled. So when you roll it horizontally, it will start covering the surface, the inner surface, and forms a thin coating. The thin coating is, as I told you, to simulate the aggregate coating. So when the bitumen coats in the particular aggregate, it will be very thin coat, around 6 to 10 microns. So this way, we will try to simulate this particular aging in the Rtfo test. So once you prepare the Rtfo bottles with bitumen, you will fix each bottle in this particular carriage. Now, when you do any test, this carriage should be always filled with all the bottles. Let's say you're testing only 2 bitumen, and you can keep keeping only 2 Rtfo bottles. But you can keep, these things should not be left empty. You need to fill the particular these holes with empty bottles, right? So then what you will do? Now once you do this, before keeping the bottles, right, you need to preheat the oven. Now you will preheat the oven for temperature of 163 degrees, right, at least for 4 hours. So why do we do that? To ensure that the whole system, right, is set up to 163 degree Celsius for at least before 4 hours of testing. So after setting the oven, then you will keep the bitumen with the Rtfo bottles and allow it to condition for 85 minutes. In the 85 minutes, what happens basically? This carriage will start rotating. It will rotate in the anti-clockwise direction. So while rotating, what happens? When it comes here, this particular pipe, right, it will push the hot air inside this Rtfo bottles, right? So this hot air will simulate the aging. So this hot air will simulate this, right? It will push the hot air and it will start aging the bitumen. This way, every bottle will be subjected to this particular hot air and it will start slowly aging, right? So this way we will simulate the short-term aging in the laboratory. So once we get this particular, after 85 minutes, what we do? We will collect the sample. Now let's say, as I told you, we can do two kind of things. One is you can determine the mass loss. Other thing, you can basically determine the rheological properties or other properties before and after aging purpose. Now let's say if you want to determine the mass loss, what we will do basically, we will take this particular Rtfo bottles. We take the Rtfo bottles, then we will allow it to cool. Right? Then after cooling, we will see what is the mass. We will compare the initial mass and the final mass and see the mass loss. But on the other hand, if you want to find some properties like before and after aging, what we will do? We will, once we get this particular aged binder, we will immediately transfer this aged binder to an empty can. Right? We will use a scraper and scrape the whole bitumen and then collect it in an empty can so that we can use the particular aged binder for further tests like measuring complex shear modulus, measuring face angle, measuring the viscosity. So this way we will simulate this particular binder to short-term aging, and then we will determine the properties to see how much aging has happened during the short-term phase, and we will see that whether the bitumen is age resistant or it is more tendency to age. This way we will simulate the short-term aging in the laboratory. So now we will be pouring 35 grams of VG30 binder in the Rtfo bottle. Now in this particular bottle we have filled some grams of bitumen. So now what we will do, we will make it horizontal position and we will slowly roll it so that it forms a thin film. In fact, one can calculate what would be the film thickness knowing the surface area and weight of the bitumen. Now we will allow this bottle to cool for around 30 to 60 minutes, that is 1 hour, so that they attain a room temperature. So after this, we will transfer these bottles to the Rtfo oven, where they will be kept in the conditioning temperature of 163 degrees for 85 minutes, right, where we simulate the short-term aging. So now what we will do, so we will, this particular Rtfo bottle filled with the bitumen forming a thin film is cooled to room temperature. So now we will place this particular Rtfo bottles in this Rtfo, this carriage or carrier, what we call, and then we will allow it to expose to the hot air, right, hot air for 85 minutes at temperature of 163 degrees. The Rtfo bottles are very expensive, so we have to be very careful while pushing it inside this particular wheel, rotating wheel. And this rotating wheel rotate at a speed of 15 rotations per minute. Right, slowly rotate so that each bottle is exposed to the hot air. And you can see the coil which will supply the hot air also. So all this operation should be done in 5 minutes so that the oven won't get to again low temperature. So immediately we close the door and we will switch on the oven immediately. Now if you see, The temperature what I getting is basically 123 degrees, and you can see how the wheel is rotating inside the Rtfo. The Rtfo bottle's carrier is rotating at a speed of 15 rotations per minute. And this will be continued for 85 minutes. So after 85 minutes we will remove the sample, and it will be stored in the next set of video. So if you see in this particular thing, there are two values. One is PV and SV. SV means set value, PV means present value. There will be some deviations from the set value and present value, right? So if you see the set is 163, but the present is 165.6. There is a deviation of around 2.6 degrees. So now we have completed 85 minutes, right? So now we will stop the oven, and what we will do, we have kept two bottles for each binder. One to determine the mass loss, where we will determine how much mass loss has been done due to the aging effect, and then the other binder, other set of bitumen will be used to do a rheological test to compare the properties of aged and unaged binder in short-term condition. So now we will be slowly removing the bottle. So you can see the testing has been stopped now. We will slowly pull the Rtfo bottle and see which is the binder we are basically taking out.